Today we are learning about Rolle's theorem. Rolle's theorem is named after Michel Rolle, who was a French mathematician who lived from 1652 to 1719. He was the first mathematician to prove this theorem, but not the first one to use it. And here is Rolle's theorem. We have a few conditions. The first is that our function is continuous on the closed interval and differentiable on the open interval. And also that f of a must be equal to f of b. So let's just start sketching something out. And let's have f of a equal to f of b. So f of a and f of b share a value. Okay, so now there exists at least one number c in the open interval such that f prime of c is equal to 0. So if we draw something that's continuous and differentiable between a and b, joining these two points, I'm just going to make something up here. Rolle's theorem says that there has to be at least one place where the derivative is equal to 0, and that looks to be true here because we have to have some sort of turning point where we have a horizontal tangent line. Now Rolle's theorem promises at least one place there could be more than one. So for example, our function can do something like this, where we have two places where the derivative is equal to 0. So let's take a look at why f must be a continuous function. Here's a, b, and we have f of a equal to f of b. But let's say we draw a function that is not continuous. Now notice, if I put that discontinuity where our turning point would have been, we don't have anywhere where the derivative is equal to 0. And why must the function be differentiable? So same start here. We've got f of a, which is equal to f of b. And let's say our function did something like this, where we have continuity, we have f of a equal to f of b, but our function is not differentiable. We do not have a place where the derivative is equal to 0. At this c, the derivative is undefined. It does not exist. So that is why our function must be differentiable on the interval. So it's important to remember that for Rolle's theorem to apply, that is for us to have a place where the derivative is equal to 0 on the interval, we must have continuity, we must have differentiability, and we must have two equal function values.